G'day, welcome to Cable HQ. Today I'm going to talk about the DSP4000 Cable Analyzer. We'll be comparing it to this cheaper continuity tester. So let's actually just start with that continuity tester. So there's nothing wrong with these cheaper devices for continuity, but they don't actually analyze it to the particular standard, for example Cat6. So here's a previously recorded result here, and you can see that it's told us that there are some cables, some wires within the cable that are being cross-connected. What I'm going to do, that's a previously recorded result. I've got a cable that looks okay here, kind of shiny and new, but let's take this to the continuity test. So here we are, continuity. I've got the cable connected, the remote at this end, and it's saying that if we go down to start, it's doing the test, and then the remote is beeping, and it says I'll just disconnect the remote because it's beeping, and we can see that it's got a valid test result, continuity. Now the thing with this cable though is it's actually a bad cable. So why did it test okay with our continuity meter? This is where the cable analysis is handy, because the cable analyzer goes a bit further than that. What it's going to do, it's going to actually send signals down the cable and see if they appear on other pairs of the cable. So that if that happened, that would be crosstalk, and there is always crosstalk, but it's just whether that exceeds the standards that are set for each cable standard. So if that's the cable under test, I'm actually going to just add a couple of cables at each end. So this cable analyzer needs a couple of meters of cable to do its analysis properly. So cable under test is this blue one, and got some Cat7 cable here which I'm going to plug in there. These cables are at each end are 3 meters long, Cat7 cables. They're previously tested okay. What I'm going to do is I'm just going to go to the test buttons. We've got to set this for Cat6 cable. Cat6 is a unshielded standard. Cat6A is with a shield and goes to a high frequency. I'm going to press test here. So it's running through all kinds of tests. Typically one of the most important tests is the crosstalk, like I was saying, where it generates signals on one pair of cables and then tries to receive those on the other pair of cables, and if the received energy in those other pairs is too high, then it will fail. And it's just coming to the end of the testing now. See the fail light did indicate here, but we can actually go in and great, so it says fail next. That's near end crosstalk. So it's cable at the transmitted end. So if we look here, we can now look at the results, all kinds of results in here. Now if we look at the passes and fails, here's the wire map. You see it passed the wire map test, as it did with the cheaper tester, but it failed on those other tests. And we can see exactly where it failed. Let's go down to the near end crosstalk. It's got a fail here, and we can see that if we go into the view plot here for these different pairs, so the smooth line at the bottom is the test standard, and the wavy line is indicating how that cable measured, and if it goes below that line at any point along that frequency, then it's a fail. And look at the next pairs as well. So it's checking all combinations of pairs. You can see right at the end here, we can actually zoom in on that as well, and just see right at the end there. Right, now what's quite a good, that's frequency along the horizontal scale there. we look at one of these other tests, we can do a kind of a, it's like kind of like a cable X-ray, where it sends a pulse down the cable and then listens for the reflection of that. So more like a cable radar than an X-ray, I guess. So these are all the different tests here. So it's failed a couple other ones. Power sum next, for example. But the interesting one really is that one where it sends, it's kind of a TDR, time domain reflectometry, which is where the pulse is sent down the cable and then it listens for results. So I'm going to do that now. It's the HD TDX analyzer. So that test is in progress now. So I've just switched to single test, so I can do a single test at once. It's a lot shorter. Right, now if we view the plots on those, we can see that that is, if I'm going to zoom in here, let's go adjust scale. Right, so what we've got there is a lot of reflections. I'm thinking that these two here, that's at 3 meters, yeah, so that's the coupler. So that bumpy bit there, what I've got here, 2 3-meter cables at each end, which are okay. Then I've got quite a cable which doesn't even meet Cat 5. It says it meets Cat 5, but doesn't. Notice there's 2 connectors here, these couplers. Those couplers can be, we're getting reflections off those couplers, and that's where that line with the cursor is at the moment, is that first coupler. That other line there, that's this coupler here. So we can actually see, it is truly like a map of the cable. So if there was a twist and some damage, and I'm not saying that there's a break in the cable, I'm just saying maybe it's twisted too tightly, maybe there's some water ingress, you would expect to see some lumpiness where those connectors aren't. And if we have a look in there, right there, see what have we got? 3 plus 3 plus 2, that's 8 meters. Yeah, so right there in the middle is that highlighted one with the cursor right in the middle between those 2 bumps. That's basically the bad cable. Now this bit right at the end, so that's the beginning cable, so we're 8 meters long, so you can see there's a bit of discontinuity at each end. So that point there is that point there, this lump here, this bit here, and like I say, then we can see that. So if that was on a wall or somewhere and you're wondering, where should I cut a hole in the wall to inspect for physical damage, well, okay, this will, especially if you calibrate it, so generally over a few meters it's going to be accurate within plus or minus 300 millimeters. So that will tell you where in the wall to cut if you have to, if you are in that situation. But more likely, I mean, cables normally fail at a connector or a coupler, but again, you may have water ingress or someone has damaged the cable. This DSP4000 will, like I said, it is like cable radar with that horizontal line as a distance and the reflection, proportional reflection in the vertical axis. Let's have a look back at some other tests here. This also connects to a computer, and all these plots and things can be downloaded and stored and compared for later. So if you go back, maybe your cable's starting to fail, go back in 6 months and you can compare it. So that you can just save that. You can set it up for different types of cable and different tests in the menu, in the setup menu. Let's go back to single test here. Oh, now you can go scanning as well. So in scanning mode, it's continually scanning the cable there. So if you've got an intermittent problem, it's now going to update that live. You can get someone else to wiggle the cable while you have a look at the graph which updates live. We'll just turn that off. We'll go back to. So these are the single tests that you can do. Takes less time, obviously. So pretty quick to do a single test. Right, now the differential result there. So let let's zoom in, I think. So we know it's, yeah, through 8 meters. So we're going to zoom in. Right. Right, so it's saying 8.4 meters. Now I could calibrate that until it's exactly 8, and that would give us some more accurate distances. But again, we can see these places where that continuity has changed in the cable, because, so not continuity, impedance has changed in the cable, the two connectors there. Next pair. Okay, so I'm just going through the different pairs now. So what I'm going to go through now, I mean that doesn't actually look too bad using that test, but clearly it failed, and the previous single test, that analyzer test, was really enlightening. I'm just going to do that one again, because I didn't go through the different pairs, I think. Let's have a look. Notice too that it's giving the peak to the, so the peak result and the distance to that peak. So basically where the worst bit of the cable is, which is right in there. So 3 plus 1 will be 4, it's saying actually 4 meters. It's actually saying 5.4 there, 3.3, 5.4. It's you know, it's somewhere in the middle of the cable there. It's going to go view plot, but this time I'm going to adjust scale here. So there's let's just zoom in till we get to a good. It's too big. Well, I'll go all the way out, so you can see it goes all the way up to half a kilometre, basically 485 meters. So I can test some quite long cables. I'm going to zoom in now, and let's go next pairs on this. Just want to zoom in a bit more. Let's have a look. Let's go for these pairs here. So it's kind of like cable X-ray. Let's go to the setup menu, where we can see there's the Cat6 definition. You can add to that yourself by just doing it, making it a little bit more custom as well. Different setup options. Date time, pretty average. You can set the degree to which external noise might affect the result. And then here's where you can set your custom cables. So you might want Cat6 cable, but you might want to then add continuity. Okay, unshielded, so let's change that to, oh, okay, so you can put in your own names for that custom cable as well. So you can, there is an adapter for a BNC adapter to convert to coaxial cable or other types of cable. Alright, just up there was where I wanted to show you that. It says shield disable, so you can select Cat6, but then you can actually enable the shield as well. So that won't quite give you Cat6A, but you can also extend the frequency as well beyond Cat6. So it's going to be very unlikely that something's going to pass Cat6 as defined here, but then with an increased frequency, which does drop just short of a Cat6A. So other things that you can change there, NVP, that's the propagation velocity, so that is going to change the measured length. So what you do is you'd alter that until you get a bit of test cable, and then you'd alter that amount until that length corresponded with the measured amount that you had, and then when you tested from there you'd have a more accurate result. Typically that's going to change a little bit with cable type, but it will also change a bit with temperature, for example. Defining your anomaly threshold, different wire maps if you don't need that. Resistance, no, okay, we don't have that. Cool. So there you have it. So these units are quite reliable and definitely come with a range of spare parts as well. Thanks for watching.